All right, now they should move. And there we go. This is our just random AI movement here. Welcome back to Arcade. I am Super Tommy, and this is part 3 of using bitECS to use the entity component system with Phaser 3. Now, if you haven't seen parts 1 and 2, definitely go back and check those out. And if you are liking this ECS entity component system series, be sure to hit like and subscribe for more videos on using ECS with Phaser 3. And when Phaser 4 comes out, we'll definitely be covering Phaser 4 as well. So subscribe so that you know when these videos come out. All right, so we left off in part 2 with our blue tank. This is our player tank, and we can move it with the arrow keys. So now what we're going to do is these 4 things that I have right here, and we're going to make a CPU component, create a CPU system, run that CPU system so that we can have a bunch of like random AI tanks, and then create those tanks that will use our CPU component and be run by our CPU system. That's where all our logic and code is. So just to recap what the entity component system is, in this case our entity is just an ID. It just represents a group of components that together provide state for an entity. And then our systems provide logic for each of those groups of components, depending on what we want them to do. So let's get started. All right, let's go to the corner here. So we're going to take a first step here and use a lot of code that will look duplicated from our player system from the last part 2. And then we're going to clean that up afterwards, just to keep things simple and so that we don't get too carried away refactoring. We're just going to get it working with this CPU component and CPU system first. All right, so we want to do a CPU component. So let's go to our components folder here. Let's make a new file. We're going to call it CPU. Now, these components are just going to be state. And if you recall, our player component was really just a tag. We used the find component from bitECS to give it the actual schema. And so in our case, we're going to copy this, but it's going to be CPU. And then we're going to actually give it some information. So our CPU is going to move around randomly. So we're just going to take some simple information there. So we're going to use time between actions, right? So this is actually the elapsed time or in between when a new action occurs. So we're just going to make it go left, right, up, down, and it's going to decide on one of those directions or to do nothing after an interval of this time. So this is going to be of types uint. I just go 32 in case we want some fairly long wait times, and then we're going to want accumulated time. So this we can keep track of how much time has passed, so that we know when we've hit time between actions. So that's also going to be uint32. Okay, so now we have our component. Let's make our CPU system that will use it. So let's come down here to systems. We're going to make a new system. Let's call it CPU system. Check some notes here. So it's going to be very similar to our player system because it's a similar idea, except instead of using the arrow keys from the player to move, we're just going to randomly pick a direction over that time between actions interval. So let's just do this from scratch though. All right, so we are going to need from bitECS the define system like we've done before. Define system, and we're going to need a query, so we just import that. Let's collapse that. And so we've been putting our systems inside a function that we call to create that system. So we're going to keep doing that here. And we're going to call this create CPU system. We do know we're going to need a scene, but let's just do some logic so that we can see how we build up to knowing what we're going to pass into this function to create our system. Now our system is simply going to return define system. This is the bitECS system, and that takes the world, or the function we give it is one that takes a world, or it's given a world, and then we can do whatever we want, and we got to return world. Okay, so in here is we're going to do the logic for CPU. So what we're saying is we're going to take some accumulated time, and then once that accumulated time is greater than or equal to the time between actions, we're going to randomly pick one of 5 actions. That's going left, going right, going up, going down, moving, or doing nothing. So let's first get our entities. It's going to use define query. Just call this query, the CPU query. And then define query, and what we want is a list of components here. So we're going to want the CPU component that we just made, a velocity component, and a rotation component. So we're going to make it very similar to our player system here. So I'm actually going to take these 2 imports, and then we're going to want to import our CPU component. Okay, so what our query is going to say is for any entity that has the component, the CPU component, the velocity component, and the rotation component, we're going to do something to them. And in here, let's call this entities, CPU query, pass in the world. Now this is going to return to us a list of entity IDs for each entity that matches this query. That means they have all 3 components. So let's loop through these entities. Oh no, I less than, and then plus plus I. Okay, so let's get the ID. So that's entities I. This is going to be the ID of the entity. So for each entity, we're going to do, we want to make sure that our accumulated time is greater than our time between actions. So in our CPU components, so let's go with, let's see, CPU dot accumulated time ID, and we want to add delta time here. Now, if you've watched our other Phaser 3 videos, you know that in our scene, in the update function, update method, we can get delta time. So there is another way to get delta time if we just have a reference to our phaser scene. That's what we're going to need here. So in our create CPU system function here, we're going to take a phaser scene. So let's import phaser from phaser.scene. Okay, so now we're going to be just given a scene when we create this CPU system in our game scene. We're going to just give the game scene in here when we do that. And to get DT, so let's come here, const DT, it's scene.game, the loop, and then the delta. So this gives us the delta between frames, or the time step here. So given that, then we can add DT, right? So now we are accumulating time every frame here for this particular entity. Oh, this should be I. And then we want to do if CPU.accumulated time ID is greater than or equal to CPU dot time between actions. Now recall, in this entity component system, we have a structure of arrays versus our more traditional setup, which is an array of structures. For example, a list of game objects is an array of game object structures. In our case, we have a structure of arrays. The CPU is itself a structure, and it has arrays in it that we index into to get the values for that specific entity. Okay, hopefully that made sense. Okay, so here we're just checking the accumulated time for this entity, this ID entity, greater than or equal to the time between actions for it as well. And if it is actually not here, we're going to do if less than, continue. So what happens here is on most runs of this update tick, we're going to add to accumulated time and then end up doing nothing until it reaches this value that is greater than or equal to this value, we're going to do nothing until we reach there. So once we do get there, we're going to want to set accumulated time back to 0 so that we can re-accumulate, right? So set the accumulated time back to 0 for that entity. And then we want to pick a direction. So let's just get a random number, right? Let's just call this rand. So phasor.math.between, not Bernstein, between, we're going to do, let's just say 0 to 20. You can pick whatever you want, 0 to 100. We're just going to do a very simple like switch here. So switch rand. So if, let's say it's 0, we're going to go left. And it's going to be relatively identical to our player system here, right? So in our case, we're doing left cursor, right cursor. So it's going to be something like this. Let me just copy that here. Boom. Break. Okay. -5. Okay, so we could define a speed, but let's just go with what we have. So case 1, and let's just say that's going to be going right. And let me just copy that. Case, so that's right. Right, so going right is x, velocity x, +5, going left, velocity x, -5, and this is the rotation. So you see we're copying a bunch of stuff here. We are going to refactor this, but for now, for simplicity's sake, let's go with this so that we understand what's happening. It's very similar to what we just did, but instead we're going to do this for CPUs instead of the actual player. You know, so it's our very, very basic AI system here. And then down, and then lastly is going to be nothing. So 3 is down. So just so that we remember, so that's left, right, up, down. And then the last one is going to be default, and that's going to be nothing. And so this 0 break. Okay, so that should be our CPU system. Great, awesome. Okay, now let's go to our game. So now we have our CPU system and we have our CPU component. We can go to our game scene. Where's that at? Here it is. Here's our game scene, and we're going to make a CPU system. Okay, so we're going to declare that just as a class property here. Come down here. Let's make our CPU system. Create CPU system. That'll auto import. Pass in that scene that we're taking into that function. Let's just make this a relative import. Now we're not going to see anything because we're not running that CPU system. So let's make sure we run it. So we can run it basically either before or after the player. It doesn't really matter, but we do need to run it before the movement system. Since the movement system, if you remember, let's go here, is what movement is what does the actual adding the velocity to the position. So this is where the math actually takes place. So we got to decide what our velocity is before we do that. So the order of when you run your systems do matter. We mentioned this in parts 1 and 2, that the order of these systems do matter. Okay, and of course the sprite is our rendering system in this case. That has to happen last. All right, so now let's make these CPU tanks. So let's just say for let I 0, I less than, we're just going to make 20 tanks. Right, it's going to be very similar to our player here. So let's go with, say, tank add entity this dot world. So we're making another tank here. And we're going to add component this dot world position tank. So we're adding a position component to our tank, and now our tank, let me just check my notes, needs to a position just like our tank up here, but we don't want it to be the same. So we're going to randomly generate some values here, and what it's going to do, just like before, phasor.math.between, and so we're just going to take some parts of the screen size here. So let's actually get, let's get it up here. So const width height. Let's get that from the scale manager. So this dot scale. And what we're gonna do is say width times 0.25, so a quarter of the screen, up to width times 0.75, so up to 3/4 of the screen. So basically we're gonna get things from like here to here roughly. And we're gonna do the same thing for Y. So we got like this little box that we're gonna use, but this is gonna be height, and this is gonna be height for Y. So that's our position. Now if we left it here, we're not gonna see any tanks. We have position, because in our rendering, let's go to our sprite system. We need sprite position rotation. So we need all those things to be rendered. So let's go to game. Let's give our tank at least a rotation. This dot world rotation tank, and add component this dot world sprite. Let's see, tank, and our sprite dot texture index into tank. That's the ID. Entities are just IDs, and we're going to just give it some value between 0 and 2, since our texture array here. So check part 2 for that, or actually part 1 is where we actually got our first tank going. If you don't need the explanation of what this is just the actual sprite keys here that we have here. Exactly how that works, check out part 1, but we're just going to give it phaser.math.between 0 and 2. And this is inclusive, sort of 1 and 2. Because blue is the player. There we go. So now we have our tanks here. Now they're rendering simply because we have all these components added to our tank. Now if we just removed one of these, our sprite system is not going to use them, and therefore we'll see nothing. Okay, so now we want to actually have these guys move. So that's where our CPU system comes into play, of course. So add component this dot world CPU tank. And let's just double check our import here. Yep, for you guys, you may want it to be relative. And for our CPU component, we have that time between actions. So CPU dot time between actions for our tank. Also going to use a random number here. So phaser dot math dot between, and let's just say 0 to 500. So that's milliseconds. Okay, so we have that. Okay, very good. Let's just double check what's not working. CPU system. So we got CPU velocity. Okay, we did not add velocity. Yeah. So now we need to also make sure we add our velocity component. So let's come up here, add component this dot world velocity tank. All right, now they should move. And there we go. This is our just random AI movement here. All right, so that's what we did here. We added our we added our CPU component to our entity component system, and that's how we have our any entities that we add with these components: position, rotation, velocity, CPU. No, I lied. It's actually just these: CPU, velocity, rotation. So any set of components that any set of entities that has these three components will be acted upon by this CPU system. And so now you see it's very similar here to our player system, right? It's very similar. We have this velocity.x, velocity.y, rotation.angle. Oops, come here, right? We're doing very similar stuff. So we can definitely refactor this so that we have a system that has shared logic, since this is basically the same. The only thing different is where the input's coming from. So we are going to do that in the next video. That's going to be the last one for this ECS series, this introduction to ECS with Phaser 3 using bitECS. Now, if you enjoyed this video, be sure to hit like and subscribe for more videos on game development for the web using the entity component system that we've covered in the past and the entity component system that we've covered in this video. Come back for part 4.